Hey, Matthew.
Hey,
How's it going?
good or going good? We're doing AP review.
I thought
Finally on that.
I thought that's what we would be doing tonight. You don't have a test tomorrow or anything, right?
No, just like a little quiz to sort of help us know where we're at.
Okay. I've got a couple of AP exams for Calc AB.
Bottom left one is the first one.
Okay.
The bottom left pictures, that's the first one.
Yeah, I'm going to just pull them all over here. And hopefully I'll open the first one. Yeah. Okay.
And we're only doing odds tonight.
Okay. The old particle moving along the x-axis. Okay, how are we going to do this one?
We'll have to take the derivative, the second derivative, right?
Yes. So, let's take the first derivative.
It'd be park the negative 1/2, negative sign.
So that makes it plus 1/2 sine.
And then minus 3.
Okay. X double prime of t.
You park the 1/2 again, and then it'd be cosine of t, 1/2 cosine of t.
So x double prime of pi over 3. What's that equal to?
Cosine of pi over 3 is what's that one again? Is that
Half.
oh, it's a half, so then it'd just be 1/2 times 1/2.
Yeah, so 1/4.
Mm-hmm.
The ones you may want to rack up to memory are the sine of 30 degrees is 1/2 and the cosine of 60 degrees is 1/2. Those are the two that are firmly locked in my memory because you have to do them so frequently, both of them.
Mm-hmm.
So as long as you can translate that to 60 degrees, you're in. So 1/4 C. Is there a reason we're not doing the even one? Is this a alignment or something? Or?
Yeah, I don't know why she just told us to do
Okay.
the odds tonight.
All right. Oh, maybe she'll have you do the evens a different time. I've gone through a whole AP Calc AB test, and I was pleasantly surprised to find that it's not as difficult as you might imagine. Have you tried looking at one yet?
No, I actually haven't.
I think these problems you're getting here are probably from an AP Calc test. They look real similar, but okay. So here, what is that, minus t squared plus 7?
Yep.
What's the velocity of the particle when its acceleration is 0?
So derivative.
Yeah, let's start by taking a couple of derivatives, I think. We're going to need both the first and the second. What's the first one?
It would be 3 cosine of t minus 2t.
Okay, and the second derivative?
Would be negative 3 sine of t minus 2.
Okay. So they said when the second derivative is equal to 0. So let's solve that. And we'll know what t to plug into the first derivative, and we'll have our answer. So how am I going to solve this?
Add 2.
So I got sine of t equals negative 2/3. So t equals the inverse sine of 2/3, negative 2/3. Do you have your calculator? Let's put a number on that.
Alrighty. Negative 0.729.
Negative 0.729. Okay. Now let's plug that in to the first derivative function and come up with an answer. So we need 3 times the cosine of negative 7.9, but that's the same as the cosine of 7.9.
It's actually 0.729.
Oh, 0.7. Of course, cosines can't be bigger than 1. What am I thinking? But notice I don't need the negative sign, because cosine of negative x is equal to cosine of x. I can dispense with that negative. Minus 2t, well, that's going to be plus 1.58. So now solve that and come up with a number. It's the cosine of 0.729 multiplied by 3 and added to 1.58.
$3.817. So I guess it's E, because that's the closest one. I guess not a rounded right.
Huh.
Because the answer is E.
Oh, okay. All right. Yeah, I'm surprised that we're that far off.
Yeah.
Because I'm sure we did it right. Notice the plus 7 disappeared with the first derivative, so it's not even a factor.
Yeah.
Yeah, no, I'm sure we did it right. Okay, so 5. Know that the United States is the only developed country in the world that gives the SAT and ACT tests as multiple choices. Every other country makes you write the answers out. Interesting. I had no idea. I heard that the other day when they were comparing the education systems of the United States and other major countries. And we're the only ones that have multiple choice tests.
That is funny.
At least for SAT and ACT. I mean, maybe for calculus it's different. They actually are changing calculus now. There are some computer program calculus tests where it's not multiple choice, and you have to actually write out the whole answer. And they are tougher than nails. It's unbelievable how tough those are. Not because the problems are, well, not because it's not multiple choice, but because you have to fit everything exactly in the right spot. You have to put the exponent in the right place. It's amazing how hard it is actually to put in the answer. All right, so here we have the velocity function. What What is the maximum acceleration of the particle on the interval?
So we take a derivative?
Yeah. So v prime of t equals a of t equals minus 3t squared plus 12t minus 15. What is the minimum acceleration of the particle on that interval?
Oh, that's a calculator one.
Well,
So
but that doesn't matter at the moment. I need to, for some reason I'm confused on this. I think, yeah, sure, this is the same problem. If I gave you a function, y equal x squared, and I say, where is the minimum value of that function? You're going to take the first derivative and set it equal to 0 and come up with the minimum occurs at x equals 0.
Mm-hmm.
Well, this is the same problem in that they're really asking, no they're not. They're not asking what the minimum speed is. Because if they were asking the minimum speed, we would take the derivative and set it equal to 0 and solve for t. But they're asking for the minimum acceleration. Well, gosh, we have an acceleration function. It's right there. The problem is it's a downward parabola. So there is no, oh, on t from 0 to 5. Okay. Okay. Let's factor out a 3, a minus 3. Factor that thing into minus 3 times t minus 3 times t minus 2. What the heck? It is a calculator problem. In other words, that thing doesn't factor nicely. However, we can find out the minimum value of the acceleration. If this is the acceleration, as t goes from 0 to 5, let's just try all the answers and see which one produces the minimum value. So when t is 0, we've got minus 15. So a of 0 is minus 15. A of 1 is minus 6. A of 2 is 4 minus 4 plus 1 minus 3. A of 3 is 9 minus 12, that's plus 2 minus 6. A of 4 is 16 minus 16 minus 15. and a of 5, because we do need to check the endpoints. That's 25 minus 20 plus 5, that's minus 30. There's your minimum acceleration at the right endpoint. Answer A?
Yeah, that's right.
Okay. Now, the question is, did I do it right? It's kind of a different kind of question. The only problem with the way I did it is I didn't check the values that were non-integer values. In other words,
decibels.
Yeah, in other words, what if there's a lower value for the acceleration when t is 2.5?
Yeah.
I'm not going to find it the way I did it. So, I know how to do it. What was I thinking? When we want the minimum acceleration, what do? That's where I was screwed up. I take the first derivative and set it equal to 0. When I set that equal to 0, I get t equal 2. And when t is equal to 2, what the heck? I erased all of it? I did. When t is equal to 2, what is our acceleration? It's minus 3 times 4 plus 24 minus 15. That's not our minimum acceleration. That's our maximum acceleration. Remember that when we take the derivative of a function and set it equal to 0, we are getting the horizontal tangent. And in this case, this is what the curve looks like. So when I set it equal to 0, I'm getting the maximum, not the minimum. In order to find the minimum, I need to check the endpoints additionally, besides just the horizontal tangent. And the endpoints are 0 and 5, and when I plug in 5, I get 30, which is smaller than this point. So this was actually the correct way to do it, not the way I did it before. Because for one thing, this gives me all the points, the decimal points. I'm not just stuck with integers.
Yeah.
But by taking the first derivative of in other words, the acceleration function looks like this. And if I'm looking for the minimum value, I'm going to take the first derivative, find out where it's equal to 0, which is there, and then check my endpoints also, which are there and there, find out whatever is the lowest value. And that's the way we did it the second time we did it. And that's the way we should have done it. Okay, so we have this position function. For positive t. Find the value of t. What does the rest of it say? It didn't get captured. For
at the value of t, what does the v... Oh, wait, that's number 6.
Yeah, number
For
6.
what value of t is the speed of the particle increasing?
Okay. Notice they said the speed, not the velocity. For what value of t is the speed of the particle increasing? Well, let's get the velocity function. if I graph that, it goes up like that. The velocity function. So the speed is increasing when the velocity is increasing. Actually, we need the acceleration function also. And that is because if they'd have said velocity, then all I would have had to do was look at the acceleration function and figure out where it's positive, right? Because the acceleration is the first derivative of velocity, and wherever velocity is increasing, acceleration has to be positive. That's the relationship between a function and its first derivative. If the function is increasing, first derivative is positive. If the function is decreasing, first derivative is negative. So I can figure out where the velocity is increasing, which will be part of the answer. That's where acceleration is positive. Acceleration is positive whenever t is greater than 4. Acceleration is positive, but it could be, that's what we want, is acceleration being positive. Let's see, if acceleration is negative, that means, I always have to think about this. This always confuses my brain.
Doesn't it have to be like velocity and acceleration have to be the same sign?
Yes, that's the answer. Velocity and acceleration have to be the same sign. In other words, if velocity is going to the left and negative, and acceleration is going to the left, it's speeding up. I think. Which would mean let's see, acceleration is increasing when t is greater than 4. It's obviously decreasing when t is less than 4. And so what's going on with the velocity function at t equal 4? What is the velocity function for equal to? Let's see, we have 3 times 16 minus 24 times 4 plus 21. So that is a negative number. That is, I think, that's 48 minus 96 plus 21. So the velocity is negative at t equal to 4. So t greater than 4 does not give us a plus-plus situation. It gives us a plus-minus. So t less than 4 gives us a minus-minus.
So that means it's going positive.
So t has to be less than 4. Or greater than 7. I didn't consider 7. 7 is where the velocity turns positive. You watch. We got 3 times 49 minus 24 times 7 plus 21. I'm betting that's a positive number. This is minus 168. This is plus 147, and 21 plus 168. So it's at t equals 7 where the velocity turns positive. We can see acceleration is also positive. So this is the answer because both are going to be negative when t is 1 to 4, and both are going to be positive when t is greater than 7. And that's the situation where speed is increasing. So 7, oh, you didn't show me the answer. What is the answer on 7? Is it D?
D.
Good.
Yeah.
All right. Those are tricky. Those are very tricky. Yes, you have to do exactly what you said. Find out where they both have the same signs. And the answer would have been different had they said, where is the velocity increasing? All right. What do we got here? What are the values of C? I used to hate these questions, but I don't think I hate them anymore. What are the values of C that satisfy Rolle's theorem on the intervals 0 to 2?
Rolle's theorem, isn't that it's 0, the derivative is 0. You go looking for where it's 0.
It's going to be where on the curve, let's draw that curve. It is a sine function that has been compressed horizontally. And what we're looking for on the interval 0 to 2, where is the slope equal to the average slope? So the average slope is what? It's sine of two pi minus the sine of 0 is the average slope, which is 0. How can that be? Oh, maybe it can be. Yeah, because this point here is probably 2. No, this point here is 2. And then I would have the sine of 2 pi, which is 0. So the average slope between 0 and 2, yeah, this function right here is the sine of pi x. And it's going to look just like this. When x is 0, we're going to have the sine of 0. So now we want to find a point on the curve that has the same slope as our average slope. Well, clearly it's there and there. Well, that point is what? And what is that point?
Since it's horizontally compressed, does that make the y values change?
Yeah, we don't really care about that. So all we care is what are the x-coordinates of those horizontal tangent lines. There are 1/2 and 3/2. Answer E. You see why?
Yeah, because that's where...
Yeah, in other words, just reading it. Now, I solved that graphically, not mathematically. Although I did have to find the average slope between those 2 points.
Mm-hmm.
And then I merely needed to find where the derivative, that's the way to solve it mathematically. I'm looking, if I take the first derivative of x, I get cosine of pi x times pi. So that's the first derivative, and I want to set that equal to 0. Well, where is pi cosine of pi x equal to 0?
At pi over 2.
Which is 1/2. And 3 pi over 2. In other words, if I look at the cosine curve, it's there and there, which are 1/2 and 3/2, only because that point is 2 right there. So we can solve this strictly mathematically without even having to graph it. Is that all on this page?
I think there's one more.
Oh, yeah. Yeah, sometimes my thing doesn't work unless I click it differently. Okay, on the closed interval, how many values of C satisfy the conclusion of the mean value theorem? Well, I'm looking for slopes that have that slope. The average slope between point A and point B. Or, yeah, actually the average slope between those 2 dots is that horizontal line. So now, what am I looking for? I'm looking for places on the function. What the mean value theorem says is that there has to be places on this function where the tangent line has that slope. Well, clearly there's one right there. There's another one right there. There's another one right there, and there's another one right there. And only those 4.
All right, that was easy.
Yeah, that's pretty much what the mean value theorem says. Is that if you have a continuous function, then the average change between point A and point B, there has to be another place on there that has that same slope. That's what it says in a nutshell. Is that right? Did you look? C for 3?
Yeah, that's right.
Yeah. So 5?
I don't know if we do that because it doesn't say.
Oh, it's
5,
a
and
free
she said something about not.
free response.
Yeah, she told us not to do that.
Okay.
Did I send you another page?
Yeah. Whoops. You were a little shaky here. You might have to send it again.
Yeah.
Can you send it?
I gotta yeah, I'll send it again.
Okay. Yeah. I mean, you could read those to me, I guess.
It says
read the first one, and then we'll work on it while we're waiting for you to send the others.
All right. It says, at what value of x does f of x equal x minus 1 cubed, x minus 1 cubed times 3 minus x?
Have an absolute maximum.
Yep.
So where's the maximum of this function? In other words, if I put this function into Wolfram alpha, it'll show me some strange looking function, and I want to find where the maximum is. So what am I going to do?
We will take the derivative.
Okay. Okay, we're going to need to use the product rule.
It'll be first is x minus 1 cubed. The second is 1 plus second. The first would be chain rule 3x minus 1 squared and then times 1.
Okay, so there's our first derivative. And we want to know where that's equal to 0. Well, we're going to have a cubic function, aren't we? In other words, that's not going to be the easiest thing to solve. Where is the absolute maximum? Is there an easier way to look at this? Yes. Let's factor out an x minus 1 squared. I think that'll make it easier. And it leaves behind a negative a 1 minus x plus 9 minus 3x. So now we have x minus 1 squared times, what do we have, 10 minus 4x? So that we have to set to 0, because that's the maximum is going to be where the tangent is 0. So now if we solve this, x can be 1, that makes that 0, or x can be 10/4 or 5/2. So these 2 points are where the tangent line is 0, but we don't know that they're maximums. They might be minimums.
But since there's only one of those on the answers, doesn't it have to be that?
Yeah, I guess so. Yeah. However, let's talk about the test. How do you determine now which is a maximum and which is a minimum? Don't we have both answers? Is this a 1 over here?
Yeah.
And this is a 5?
Oh, yeah, there's... Yeah.
Yeah, so we do have to keep going. There is a first derivative test, and there is a second derivative test. The first derivative test, if it's a maximum, then the derivative will go from plus to minus. If it is a minimum, the derivative will go from minus to plus. So let's see which one we have here. Let's substitute not 1, but a number to the left of 1. You see why? Because 1 is right there. So if we're going to apply the first derivative test, we need to check what is right less than 1. Well, what is the first derivative? This is the first derivative, f prime of x. When I use a number left of 1, this is positive, this is positive.
Positive.
So it's positive. And when I use a number to the right of 1, This is positive. This is positive. So
1 doesn't change.
yeah, which means that it does something like this. In other words, our horizontal slope is not at a maximum or a minimum. It's like y equal x cubed. There's a spot right there where your slope is 0, but it's not neither a maximum or a minimum because the slope doesn't change on either side of it. Now let's look at 5 halves. Well, when I put 5 halves, when I go to the left of 5 halves, let's say the number 2 would be to the left of 5 halves. Well, this is positive. This is positive. So there's our positive to the left of 5 halves. When I go to the right of 5 halves, say the number 3, that's positive, but this is negative. So we go from positive to negative at 5 halves, so that's the maximum.
All right.
Did you send me another one, or were you going to read them all?
I sent you another one, I believe.
Actually, I can almost read this one, so I don't. Let's see. What is the minimum value of f of x equals at x cubed or squared?
X squared natural log of x.
Okay. So first of all, let's differentiate it. Go ahead. F prime of x.
Derivative, it'd be first x squared d second, the derivative natural. Is that 1 over x? Yeah. Over x time plus second natural log of x d first is 2x.
Okay.
And then we set that equal to 0, right?
Well, first of all, let's simplify it. That's just x. So we're solving this. How am I going to solve that?
We would factor on x.
Yeah. Now, the two 0 points are where x is 0, and this can't be 0, ever. Yes, it can. Excuse me. Yeah, let's solve that.
Would it be...
In other words, I've got 2 natural log of x equals minus 1, so natural log of x is equal to minus 1/2. So I've got e to the minus 1/2 equal x. So there's the second place. So there's 2 places that have horizontal tangents. Now, to figure out which one is a minimum, let's this time apply the second derivative test. You know how to use the first derivative test, right? From the last problem we did?
Yeah.
You have to pick points left and right and see what the slope does. Well, the second derivative test is a little more straightforward. It merely has to be positive for a minimum and negative for a maximum. Because if the second derivative is positive, it means it's concave up. If the second derivative is negative, it means it's concave down. So the negative would give you a maximum, the positive would give you a minimum. So let's see what the second derivative is. F double prime of x equals 1 plus 2 plus 2 natural log of x, or 3 plus 2 natural log of x. So let's evaluate this at our 2 points. Can we even evaluate it at 0? No, because you can't take the natural log of 0. So the only thing we can even evaluate it at is e to the minus 1/2. What do we have here? 3. So f double prime of x equals 3 plus, what was that, 2 natural log x? And we're looking for minimums, so we want to know where this thing is greater than 0. When the second derivative is positive, it's going to be concave up, and that will be a minimum. Well, this would mean that natural log of x would have to be greater than minus 3/2. Well, that's pretty easy. Hold on a moment. I got confused. So whenever, wow, if the natural log has to be greater than minus 3/2, what does that mean about x? X, is one of these answers e to the minus 1/2? Yeah, D is. So if natural log of x is greater than minus 3/2, then x has to be what? Is it positive? Well, x has to be positive anyway.
Yeah.
Yeah, so x is positive by definition the moment we solve the second derivative. No matter what, for this thing to be greater than 0, it's always greater than 0 for all x. No, it isn't. But it is for x of e to the minus 1/2. In other words, if I take 3 plus 2 times the log of e to the minus 1/2, that is a positive number. Natural log of e to the minus 1/2 is just minus 1/2 times 2 is minus 1 plus 3, that's equal to 2, a positive number. Therefore, that is the minimum by the second derivative test. And I also could have used the first derivative test. It just would have been a little more complicated because we've got this strange looking number here. Going left and right of that number might have been a little difficult. So is D the right answer for 3?
No.
No.
It's B.
For 3.
Yeah.
Did I do my math right? I think I forgot to divide by, oh no, hold on. We had, let's see, this was x squared over x plus 2x, so this turned into just x So this was the first derivative, right?
Uh-huh.
And we need that to be equal to 0. That thing can't be equal to 0. Can it? Yes, it can. In other words, if you take the log of a number between 0 and 1, you get negative.
Mm-hmm.
Okay, so that can be negative. This would be negative because we're restricted to x's that are positive only. This would be positive, so this could be 0. Where is it 0? It's 0 when x is equal to minus 2x log x. Divide both sides by x, and I get 1 equals minus 2 log of x. Okay, we're getting there. I'm going to come up with that answer. I don't know how I messed it up the first time through, but I see what's happening now. Okay, so this becomes the log of x equals negative 1/2, which means x equals e to the negative 1/2, which is not the answer. That is D. I keep coming up with D. Okay, hold on. I'm not done yet. I'm going to put this function into Wolfram alpha, and we'll just see where that minimum is. Y equals x raised to the 2 natural log of x. It's the blue part. The orange is the imaginary part. And what do they want? We're a minimum?
Yeah, the relative minimum. Or the minimum.
Okay. And we know x has to be positive. So it's this point right there, which is, looks like about 0.6. So 0.6, when x is equal to 0.6, is that 1 over 2e? I don't think so.
Negative 1 over 2.
Well, it's definitely not negative 1 over 2e. There's no way that's the right answer. Yes it is. Excuse me. I was looking for the x value this whole time. The x value was e to the minus 1/2. But it's looking for the y value. What is the minimum value of f of x? Well, I know that it comes at e to the minus 1/2, so let's plug in e to the minus 1/2 here. So we have e to the minus 1/2 squared times the natural log of e to the minus 1/2. And that is, well, natural log of e to the minus 1/2 is minus 1/2. So we get minus 1/2 over the square root of e. It's missing the square root.
What?
Minus 1/2 times e to the minus 1/2. Well, that's minus 1/2 times 1 over e to the 1/2, which is close to
I'm
you.
opening up her email she sent us to see what she did.
On 3. Oh, she's got it, her steps. Yeah, that's right. I forgot you have that teacher that does a real good job with that.
Go into it. All right, so she did get 1 over the square root of e for the x value. And then when she plugged it into the y value, f of 1 over square root of e equals 1 over the square root of e squared times the natural log of 1 over the square root of e.
Oh, I didn't square it. That's what I didn't do. I didn't square it. When you square it, yeah, you lose the square root. See this 2 right here? I was supposed to square it. It's e to the minus 1/2 squared, which becomes e to the minus 1. That's how you end up with an e down there without the square root.
Alright.
Yeah, f of e to the minus 1/2 is equal to this. I just did my math wrong. Sorry.
Alright.
Okay, a polynomial has a relative minimum at 3 comma minus 3 and no other critical points. What's the rest of it say?
How many zeros does f of x have?
Okay, so a polynomial at 3 minus 3, right there, has a relative minimum and no other critical points. So it could look something like that. What's the next question say? What's the rest of it say?
How many zeros does f of x have? Couldn't it be infinite? Like however you draw it?
No, because the more times I cross the x-axis, creates critical points. Each one of those is a critical point, which means I can only cross the x-axis twice. B.
Alright, I'll look. Yep. B it is.
The moment I try to cross the x-axis another time, I create another critical point. So that's kind of worth knowing, actually. Is that it?
Yep.
Okay. Good work.
Alright. Thank you.
I got all week off next week. If you want a lot of calculus, hit me up.
I've got it. I've been to spring break.
You're going to be enjoying your spring break, I know.
Yep.
All right. Matthew, I'll talk to you in a couple weeks probably.
Alright. Bye. Thanks.